And welcome back. So it's the 3rd of Jan today. Usual thing, pause the video, have a go at all the questions, and I'll be starting in 3, 2, 1. First question. Okay, your first question is not too bad today, is it? So it's just a rearranging to make W the subject. What makes this further maths rather than a single maths or normal maths is that the W is repeated twice. Although, again, in normal maths, they've started asking these questions a bit more, so a bit less valid now. Either way, how would I do this? Well, I'm going to get rid of the denominator first, so multiply both sides by W, which gives me YW equals 5x plus 5W. Collect all the W's on the left, all the terms with W in, I should say, and everything that doesn't have a W in on the right. So that's going to give me this here. You'll notice I've factorised already. Divide by y minus 5, and that's given me W on its own is equal to 5x over y minus 5. Nice, easy question to get us going today. Next question. All right, notably more difficult. This was introduced in the new GCSE, which is now about 5, 6, 7 years old, whatever it might be. Definitely a step up, but it's become a lot more common. So I would say this is both exams, both further maths and normal maths as well. How do you approach this? Well, hopefully you straight away recognise that 32 is 2 to the power of 5. And you know 16 is 2 to the power of 4 and 4 is 2 to the power of 2. In other words, I change all my bases to 2. So let's do that one by one. So 16 is 2 to the power of 4, still to the power of 2x plus 5. 4 is 2 to the power of 2, and 32, as I've said, is 2 to the power of 5. Then let's tidy up this numerator here. So brackets mean multiply, so that's going to be 2 to the 8x plus 20. Brackets means multiply, so that's 2 to the 2x, and that still equals 2 to the 5. And crucially, all my bases are now 2. So I can just use one big index rule, so 8x plus 20 minus 2x is equal to 5. I can then collect my x's, rearrange, and x is equal to minus 15 over 6. Now, you probably get full marks for that, but hopefully you also recognise I can simplify this down to minus 5 over 2. If the question said in simplest form, obviously you'd have to do that, but you'd probably get away with it as an equivalent answer. Next question. All right, quite a lot going on here, so let's walk through this one carefully. Now, if you have a big question like this, it is worth just reading all the question to know where you're going, especially when it starts you off with a show that with no real help as to what to do. So what do I notice? Well, I notice I've got a compound shape, so straight away I'm going to think about this shape being in 2 areas. I'm also going to recognise that I'll probably need to know my distance all the way across here. But as I say, let's read the question first. So it tells me the perimeter, and it tells me what the value of that perimeter is. That seems relevant. Then I've got an A, in other words, the area is in terms of x only, and there is no y. So I'm going to use my y here in order to get my area in terms of x only. So the only thing I can do is use a perimeter. So even though it doesn't say using the perimeter, that's my best guess as to what I'm going to do. So how do I work out a perimeter? Well, I'm going to start at my little dot here. I'm going to work my way all the way around clockwise. I'm going to build up an equation with my perimeter in. So let's do that. Well, before I do that, it'd be helpful to write down clearly what this length at the bottom is. So it's going to be x plus 2 plus x plus 3 plus x. So in other words, x plus 2 plus x plus 3 plus x, which is 3x plus 5. Makes it neater, less likely to make stupid errors trying to do it all in your head. And I said, even though I teach this in year 7 or first year or primary school, wherever you've learned it, still do it carefully to not mess up the bit, to make a silly mistake. So I'm going to start here, walk the way around. So my perimeter is x plus 2 plus 2x plus x plus 3 plus 2x, etc., etc. Let's walk all the way around. Let's collect my terms and let's equal that to the 120 it tells me in the question. Now I can move the 10 across and divide by 2. So move the 10 across, divide by 2, and that tells me that y equals 55 minus 5x. This is a show that question, which means very specifically there are marks for showing various things and showing various steps. The mark scheme itself is quite open in what you have to show, but you probably have to show at least 2 or 3 lines of working that explains how you've got to the final answer. Because it gives you the answer. You can't just write some stuff down and then pretend you've got the answer. The markers, i.e. what I tend to do when I do the marking each year, the markers will be looking for various steps being done. So make sure you've shown that clearly. Right, next step. Show that A equals, or the area of the shape is A, so therefore I'm going to work out my area. How do I do that? Well, I'm going to do this rectangle at the top plus this rectangle at the bottom. So I've got 2x times x plus 3, so that's my first bit. Then I'm going to add on 3x plus 5 times y. Now, again, and this is, I have to say, this is a bit more A-level than it is GCSE at this stage, but it's good practice for where we're going if you do take maths at A-level. Equally, if you like this sort of thing, definitely do maths at A-level, because you'll find this happens a lot and is quite fun and easy to do relatively. Anyway, point is, I haven't got any y's in, so I'm going to use the y here and substitute it for this y here. So in other words, I've changed to 55 minus 5x. I do some expanding and do some collecting, and I do some expanding and do some collecting, and I do indeed get the answer that I need. Again, it's a show that question. So I need to show I've built up the area, I need to show I've done the substitution, I need to show some algebra in between. So part 1 and part 2 done. Right, part 3. I'd say up until this part, it's tough, but it could be a GCSE question. This is not a GCSE question, this is a further maths question. Use differentiation to find the value of x for which a is a maximum. I've got a, so I'm going to work out dA dx. So let's do dA dx. So I'm going to differentiate this thing here, which is going to be 146 minus 26x. And the maximum is defined to be where dA dx is equal to, well, I've written dy dx, but I mean dA dx is equal to 0. So in other words, this is equal to 0, which means that x is equal to 73 over 13. Always go back and check the question. Use differentiation. I've done that to find the value of x, for which a is the maximum. I've got the value of x, question done, and that is today done. Much harder question at the end. I would say that's much closer to an A-level style question at the end. So if you got that, well done. As ever, like, comment, subscribe, usual thing, and I'll see you tomorrow for the 4th of January. Thanks all. Bye.